Welcome to the first lab sessions for the agent-based simulations. So in this video, I will guide you in using AnyLogic to implement an agent-based simulation model. This lab session is taken from the AnyLogic in 3 days book. So in this video, we will do phase 1 until phase 4, and I will leave phase 5 and 6 as an exercise. In phase 1 until phase 4, you will learn how to specify agent's characteristics or agent properties. You will learn how to specify agent's behavior using a state chart. And you will also learn about how to run a simulation model and how to create a chart to display the simulation output at runtime. Let us get into the detail. When you run AnyLogic, you will see this welcome page. You can leave it checked if you want to see this the next time you run AnyLogic, or you can uncheck it if you don't want to see it anymore. If you uncheck this one and at some point you want to see the welcome page again, what you need to do is go to help and then click on welcome. You can also find the example models if you click on example models, or you can simply click on the open examples. Here you can see a lot of examples. To me, it is easier to learn AnyLogic by going through the examples. The one that I find it quite useful is the how to models. If you click on how to models, then you see a lot of tips and techniques to implement something. For example, if you want to know more about how to implement network, you can see here there is an example called Agent Network and Layout Demos. Okay, now let us start. So let's close the welcome page. In order to create a new model, we simply click on File, New, and choose New Model All, or the shortcut is Ctrl-N. Now you need to give a name to your model. Let's say you call it market in this case. You can store the models in any location that you like. We want to set the model time units to days, so choose days. So we can leave the rest as it is, and then we can click finish now. Now our model has been created. Here you can see that the existing models that we have already opened will be shown. So let me just close the rest because to make it easier, so close others. Okay. Now if you look at the interface, here you have the projects. You have just seen that all the projects, open projects, will be shown in here. Now previously I had 3 open projects. Now I have closed the other 2. Now I have only 1 open project. Now there is another tab called palette. So this is the one that contains all the modeling components that you need. Since we are in the agent-based simulation, we are more interested in one of the palettes called agents. So if you click agents, the palette contents will change. So this is the model components that are commonly used for agent-based simulations. I said commonly used because you can always mix and match components from different palettes. And that is one of the key strengths of AnyLogic, because you can do hybrid simulation models. Now here, this is the main editor. This is the canvas. This is where you draw your model. Property windows is where you want to specify the details about your model. Let us now see the projects again to see a bit to see the structure of the project. If you look at here in AnyLogic, the project has a tree structure. If you are from the programming background, you can think this one is an object-oriented programming. If not, you can simply think this one as a tree. So inside the market project, you have main. This will be created automatically by AnyLogic. This is where you specify your model. Okay. Now inside this, if you click on this button, then you will see the component of the mains. So you can see here, you can always expand the subset of the tree until the lowest level. Okay, so this is how you navigate across the component of your model or the component of your project. Yeah. Okay, so let us now create our first agent. So this is step 9. The way you do it is you need to go to palette, agents, and then drag it to your main canvas. So here, as I explained in the lecture, you will be given three options. Let's say we want to create a population of agents. So basically you define an agent type and automatically you will create a number of agents from the agent type. Let's click. You have to give a name now to your agents. Let's call it in our case, let's call it consumer. Let's call it consumers. Then if you notice here, AnyLogic automatically create the population names for your agent. So leave it as it is. Now we can click next. Here you can specify the animations for your agent, for your consumer. So in 3D we can specify this. In 2D, for example, let's say we specify person here. Okay. So we can go click next. Now this is where you can specify parameters for your agents. So parameters is used to implement what we call properties of an agent. This is the one that defines the characteristics of an agent. Okay, let's say our consumer has a parameter called add effectiveness. So click add new, call it add effectiveness, and let's say the default value is 0.01. So it means that this will represent the responsiveness of this agent to advertisement. Let's click next. We can always add new parameters later on. So if you forget to add a new parameter, don't worry. Okay, so because we can always add it later. Let us click next now. Let's suppose we want to create 5,000 agents instead of 100. So basically we are saying here now, after I defined the agent type earlier, so remember when I define the agent type, I define the property or the parameters of the agent. So that means that each agent will have a parameter called or a property called add effectiveness. So I want to create 5,000 agents from that agent type. So, okay, so I think we are quite happy with this one. Now we can simply click next. Now this is where you can specify the environment of your agents. So let's say we want our agent to live in a continuous space. So we use the Euclidean space. And the size, I think we can leave it as it is, 500 times 500. And we want to assign networks between agents. So we can click apply random layout. Again, if you forget to do this one, don't worry because we can always do it later. Okay, but for now, let's check apply random layout here. Now we have done. Let's click finish. Now you can see that the AnyLogic has already created the populations of consumers inside main. Now if you want to look at the agent type consumer that we have created, you can double click on it to show the agent type on the screen, on the canvas. Now you can see here our agent type is quite simple at the moment. This is the name of the agent type, and this is the animation of your agent type, and this is the parameter or the property of your consumer. Okay. Now, as I said earlier, so this is the agent type. The model now comprises a population of consumers. Every time you click a component on the project file, you can see the property windows change. This is where you can specify the detail of your components. Let's say we want to click on the consumers. Here, if we click the parameters preview, we can see the parameter that we defined earlier at effectiveness. So we can see the detail of the consumer. This is where we can add more detailed information to your agent. And that's it. We have finished step 22. Let us now move to step 23. As I said earlier, we can inspect the components of our model by exploring the tree structure on the project type. So we know that we have a project called market. There is an asterisk starts here. It means that we haven't saved our model since the last update, since the last change. It is always a good idea for you to save your work regularly. So let's save it. You can either click File and then Save, or use a shortcut using Control S. So let us save it. So click on the model, so click on the project and then File, Save, or you can use the shortcut Control S. You can see here the asterisk sign is gone. So if you click here, we can explore. Oh, okay. So this shows that our market project contains a number of components. This is the consumer. This is the agent type that we call consumer that we created earlier. So if you click on this, if you expand this node, then we know that inside consumer there are a number of components. One of them is the parameters or properties of the consumer. So in this case, like if you expand further, we know that inside the parameters we can find the parameter that we defined earlier. Okay. Now if you click on the add effectiveness, you will see the detail on the property. So let's click here. Now you can see here the detail of the add effectiveness parameter is shown on the properties window. And if you notice, whenever you click a different component, the content of the properties window will change accordingly. Let's explore the main, for example. If we expand main, you can see here inside mains the populations of agents. It will be located inside this agents node. If I expand this node, then you will see, oh, you have one population called consumers, which is true, right? We have created only one population. This also shows that in AnyLogic you can create multiple agent types. So one model can contain multiple agent types. And it also means we can create multiple populations. It doesn't mean that each agent type will need a unique population. You can always mix different agent types into one population. Yeah. Okay, now let us move on to step 25. On the main tab, you can see here, this is where you define where your consumers are. A quick note here, in AnyLogic, your canvas will be divided into a number of regions. These regions by default will be visible when you run your simulation model. The rest of the regions are invisible unless you scroll it later on. I'll show you later when we run it. Okay. Now this is where you will visualize your agents on the canvas. This is to define where you will visualize your agents when you run the simulation model. So if you click on this icon, which define the animations, if you look at advanced, let's check draw agents with offset to these positions. If I check this one, it means that your agents will be drawn relative to these positions. So in this case, because we defined earlier that the agent lives in a continuous space 500 times 500, the top left corner of your continuous space 500 times 500 is in here. So you can imagine that later on, when you run the simulation model, all the agents will be shown around these regions, 500 by 500. Okay, we can now compile our model by clicking this button, which is called Build Model, or the shortcut is F7. Let's click it. And if you don't make any mistakes on the bar, on the status bar below, it will show build completed successfully. Now we can run the model. To run the model, you simply click on this button or click on the inverted triangle here, or the small triangle here to see, okay, because there is only one, so you can simply choose that one. So you can see here, we run the market model, we run the simulation. So if you click on simulations, just to run this model, you simply need to click this. Okay, now you can see the result. Remember that we specify that the top left corner of where agent lives, which is the continuous space 500 times 500, are located in here. And there are 5,000. The number 5,000 here shows that there are 5,000 agents, 5,000 consumers living in this space. So as I said earlier, the rest of the regions, the invisible regions, will not be shown unless you scroll your screen. So by default, the rest of the regions are not visible. Only this region will be visible initially when you run your simulation model. So you can also notice several buttons here. That this is the standard start and pause button. This is the stop button. And if you want to run your model faster, you simply click plus sign here. Or if you want to slow it down, you can click minus here. And if you want to return it to real time, so you can simply click on this button. Okay. All right. I think that's it for phase 1. See you in phase 2. Now we are in phase 2. In this phase, we want to define the behavior of the agents. Remember, in phase 1, we simply create 5,000 agents at random positions in 500 by 500 continuous space. In this phase, we will define the behavior of the agents. So in phase 1, the agents have no behavior. As you remember from my lecture, one way of defining behavior is by creating a state chart that defines the agent behavior. To define the agent behavior, we need to open the agent's canvas. That can be done by double click on the consumer, the agent type that we want to modify. Okay, so let's see, double click on consumer. Now that will bring the consumer canvas on the screen. Okay, let's now draw the state chart. So go to palette and then choose the state chart entry point, because all state chart will need an entry point. We can leave the name as it is, or you can change it to something else. It's up to you. Let us add the first state by dragging this one until it touches the arrow. So if you notice, the color of the arrow will change when they touch each other. So make sure they touch each other. And then you can name this one as potential user. Potential user. And enter. So you can see here, you can resize it if you want it. You can move the text if you like, or you can resize the box. You can also move the whole thing as well. You can move things around, so don't be afraid, as long as make sure the connections is maintained. So the color, in this case, the color has to be green, the color of the connections. Okay. Step 6 is for us to change the color of the state chart. So this has nothing to do with the modeling. This is only cosmetic. But if you want to do it, so you can click on the state. Yeah, so look at the properties. You can change the color, the default color, by, so in this case, let's choose lavender. Yeah, let's choose lavender. Okay. Now, the entry actions, as I mentioned in the lecture, action means commands. Action is similar to command in programming language. Entry action is executed whenever an agent enters into this state. So in this case, the potential user state. Let's type shape body. Remember, AnyLogic is case sensitive. So remember to put a capital B there. So the good thing about AnyLogic is that you don't have to memorize all the commands because they provide a context sensitive help. So in this case, if you press control space, it will give you a list of commands that you can select. In this case, the one that I want to choose is set fill color. If you click on set fill color, it will give you help. It will give you the further information about the functions. Yeah, so let's click this one. AnyLogic reminds you that you need to specify fill color. So let us change the fill color to lavender. Now this command means that when an agent, a consumer, becomes a potential user, then the color of the agent will change to lavender. So remember, when you change the color of the state chart here to lavender, there is only cosmetic inside the agent. So the color lavender will not, so the color of the agent will still be black as shown in here. So when you run the simulation model, the color is still black until you specify this command shape body set fill color lavender. It means that the agents, the person here will be shown in lavender. Later you can see when we run the simulation. Okay. Now for those of you who are familiar with object-oriented programming or computer programming in general, you can see here that shape body is an object inside our consumer object. Now inside this object, this object has a function called set fill color. So for those who are familiar with programming, they can see we are in a way writing a code, computer code here. Okay. If you're not familiar with programming, that's fine, because AnyLogic is easier for us to write the code. So now let us draw the second state. Let's call it user. In this case, let's change the color from default to yellow-green. Now we can do the same for the entry actions. So either you type it again or you simply want to copy and paste from this one. So you can highlight it and then Control-C to copy as usual. Click on here, go to the entry action and then Control-V to paste it. You simply need to change this one to yellow-green. Again, remember that AnyLogic is case sensitive, so use capital G. Next, let's draw the transition between potential user to user. So click on transition, you can drag it here. One end of the arrow is attached to potential user, which is what we want now, but this one is not. So let's drag it until it is connected to the user. So by default, the transition is timeout. And we want to change this one to red. Let's change timeout to red. The red is add effectiveness. And this one is already correct per day. Okay, so let us see how it works. Let us build the model. So now we will expect when a consumer changes from potential user to user, the color will change from lavender to yellow-green. So let's run it. Because we have only one simulation here, so we can simply just click the green button to run it. If we have more than one simulations, then you have to select one of them by clicking the black triangle, the black small triangle. Yeah, you can see here, right? Initially, all agents, all consumers were potential users. Over time, they will become users. Okay, so we can make it faster, and then we can stop it. In phase 3, we want to collect some statistics. Remember, every model must produce at least one output. So in this case, we are interested in counting the number of users over time. Now, logically, we can only count the number of users from the populations. So let's look at our model on the main canvas. We have our agents or the consumers here. They live in 500 by 500 continuous space. So what we need to do is we need to count among all those agents living in this region, how many of them are users. To do that, if you click on the consumers, so if you expand statistics, this is where we can define the statistics at the population level. Let's click add. Now we want to count two things here. One is the number of potential users and the number of users. So we call it this function or this statistics and potential. We select count because we want to count the number of potential users. So what is the condition for someone to be a potential user? The agent has to be in potential user state. So that's what we need to specify here. How to specify an agent inside the population. Remember, now we are inside the populations and we want to identify individual agent. To do that, to identify each individual agent, what you need to type in here is item. But if you don't remember, hover your mouse to this small light bulb, and then you will see use item to identify agent of the population. So that gives you a hint. So let's type item, and then we want to know what is the state of the item, what is the state of the agent. If you don't remember the functions, you can simply use the context sensitive help by pressing Control space. So it will give you with a list of function and properties that you can use. In this case, I want to use instead, which is this one. If you look at here, there is a help here of further information about how to use this function. So this function will return true if the corresponding state job of this agent is at the specified state. So let's choose this one, click on it, and specify the state. So remember, we have the state potential user, but the state is inside consumer, inside the agent, is not inside main. Look at here. So we are now in here, in consumers, and we want to access the state chart inside the consumer. So we cannot simply type potential user, but we have to specify where it is. So we have to go back to consumer. So that's why we type consumer. So it means that we are now in here, and then we can access the state chart, which is state potential user. Let us do the same now for user. So click plus again. Now let's do this one for n user, and then still count. You can copy this one and paste it in here. All that we need to change is the state is user. We have finished step 5. Let's move on to step 6. Collecting statistics is good, but it's difficult to see it when we run the simulation. So it is a good idea to show some display. So in this case, let us create a time stack chart. So go to the palette, choose the analysis. Analysis palette contains all modules that we need to draw a chart or to collect statistics or to connect with a dataset. Or you can think dataset as a table, Excel worksheet. So what we want to use here is the what we call the time stack chart. So you need to simply drag it to the canvas. Let's put it in here. Inside the chart, if you look at the properties, we need to define what value that we want to display. So let's say we are interested in displaying, oh, by the way, if your version doesn't show this bit, don't worry, you can always click plus sign to add. Okay. So let's say in this case, because we have seen this one already, so it's simply just type in, let's say potential user. So what is the value that we want to show? So in this case, the value will be the statistics that we have just created, which is consumers dot n potential. When we define the statistics earlier, internally it's the same as defining a function. So in this case, we have to specify the brackets because n potential is a function. Let's make the color consistent. The color for potential user is lavender, so let's make it lavender. So now we can add the second curve. For this one, we are interested to calculate the number of users. And similarly for the value, we are interested in consumers dot n user. Again, don't forget the bracket, and then change the color to make it consistent with yellow, green. So AnyLogic helps us to visualize what it looks like. So this will show the potential users, and then on top of the potential users, we can see number of users. Next, what we need to specify is the scale. This is where we need to specify the time windows. For example, in this case, let's simulate our model for 1 year. So change this one to 1 and then run it for 1 year. We can, for the vertical scale, we can make it automatic, or because we know that the number of consumers is 5,000, we can put it as fixed to from 1 to 5,000. Now the next one that we need to specify is the data update. So if you click on the data update, so we need to update the data automatically. So it will be the data will be updated automatically. So leave it as it is. Now what we need to specify now is how many data points that will be shown when we run the simulations. In this case, probably we want to show the whole 1 year data point. So I type in 365 days. We can leave the rest the same. The next thing that we want to change is the appearance. So in this case, we want the horizontal axis labels to be below and the vertical axis to be on the left. Yeah, the labels to be on the left, which is the standard. The time axis format, in this case, is we can specify one that is suitable for us. We can use the American style, or we can use the British style. It's really up to you. You can define in any way you like. Yeah, I'm going to use the British style, so it's this one. So now let us run our model. Build the model first to check if we have made any error. Now it's successful, so we can simply run it now. So you can see that the chart is overlapped with the agents. Let us move the agents a bit to the right. So let's stop first and close it. So let's move the agents visualization to slightly to the right, so it will not overlap with our chart. Or maybe makes the charts a bit longer, so make it next to each other. Maybe let's put it in here, and let's put the charts in here to make it a bit more tidy. Yeah. Okay. Let's do it this way, and then okay, build, and then run. Yeah. So now we can see our model as the number of user increases. You can see here from the chart. Now you can clearly see that the curve on the chart is, we need to swap them because it looks nicer if we can see the growth of the user instead of the decline of the potential users. So again, let us stop here. Let us change that one, close it. Now that can be done by swapping this the data point. So you simply click on one of the data. I want to move it down, so I click on the down arrow here, and that's it. So you can simply compile it, and then let's run it again. Now let's make it faster so you can see the result very quickly. Okay, so that is the end of phase 3. Let us move on to phase 4. In phase 4, we want to add the effect of word of mouth to the behavior of our consumers. To do this, we need to add 2 more parameters to our agent type. Let us open the consumer canvas. So you can see that we already have 1 parameter. Let us add 2 more parameters. So click on agent palette, drag a parameter to the canvas. Let's call the first parameter to be contact rate, and specify the value to be 1 per day. Let's add another parameter. Let us call it adoption fractions. Let us specify the value to be 0.01. For those who are not familiar with computer programming, every variable or parameter will have a type. Double means a real number, so you can have fractions. So if you want it to be integer number, then you can specify it to be int. And if you want the parameter or the variable to store a text, then you can specify it to be string, and so on and so forth. In this case, we want it to be double. a real number. Yeah, because we wanted to store a real number with fraction. Once we define two new parameters, let us add new transitions. So the first transition that we want to define is contact. So let's click this one and then make sure that one of them is attached to the users, and then now you can drag the other one, the other end of the arrow, to user as well. So make sure both of them are connected. You can move this around as you wish. Let us call this transitions contact, and it's triggered by a rate, and we want the rate to be what we specify in the contact rate, and the unit is per day. Here we need to define the actions. Contact rate basically define how many times on average a user will do these transitions. So once a day on average. In actions, we need to specify when the agent does these transitions, what actions that need to be executed. So in this case, we simply want the agent to send a message to another agent at random. So in this case, the command is send to random. And the message is bye. If you notice here, I add semicolons. This is because send to random is a command. We need to put semicolon to mark the end of one command, because you can have multiple commands, so each command will be separated by a semicolon, just like in some programming languages like Java or C++. We can leave the gap to be blank because we want this to be unconditional. Let's define the word of mouth transition now. Okay, so make sure the other end, both ends attached to a state. Okay, so in this case, the transitions that we want is a message. Let's call these transitions warm, word of mouth. Yeah, and let's make it message. So we want the potential user to react to these transitions upon receiving a specific message, which is bye, the one that we specified earlier. Let's click bye. Okay. Now we want to model a bit of resistance or reluctance from a potential user. So that can be implemented by putting a guard here. So in this case, for the guard, we will use a function called random true, which will generate true or false depending on the probability that we will specify in the bracket. So the probability is, let's say, we use adoption fractions. If you still remember, we specified to be 1%. So basically, it says that there is a 1% chance that a potential user will accept that message. So let us now compile our model, and then we run it. So now we can see that the growth is steeper in comparison to the previous one. So it means that the word of mouth has an effect here. Okay. One more thing that you notice is that our simulation doesn't stop. It will continue to run until we press the stop button. Okay. So how can we specify that the simulation should stop after, let's say, 1 year? Okay, let's do that. Stop this one. Now to specify the simulation to stop at a certain time, or to set the stopping condition of the simulations, can you guess where should we specify it? Obviously not in the agent type. Probably in the model. That makes sense, but AnyLogic does it even better, because AnyLogic really separates between the model and the running of the model or the simulations. Yeah, so main is our model, but the running of the model or the simulation is located in here. So if you want to specify anything to do with the running of a model, you need to click it on the simulation. Okay, so if you click on the simulation, you can see under properties, and if you look at the stopping condition, it says never. So it never stops until we click the button or until something goes wrong with the model. So we need to stop at a specified time. So just select that one, and then let's say the stopping time is 365. Remember that the unit of time in our model we organize is days, as we have specified in the beginning. Okay. Another thing that you need to know is that you can also change the randomness setting. So if you use fixed seed, it means that every time you run the simulation model, it will always give the same output for the same seed value. So if you keep the seed value to 1, then you will always get the same results. In a way, there is no randomness. Okay? So if you want to run it multiple times and to get different results every time you run it, you can either use fixed seed with different seed value, or you can let AnyLogic set a random seed value. So in this case, you can click this one. In this case, then every time you run the simulations, the output will be different because we will use different sequence of random values. Okay, so let us now compile the model and run it. And the model now should stop when the simulation reaches 1 year in simulation time. So let's make it faster. Yeah, there you are. The simulation model stops automatically after 365 days. And that is the end of phase 4. I will leave phase 5 and 6 as an exercise. If you want to know more about my work, you can visit my personal website at psongo@wordpress.com. See you in the next video.